Hey there, it's me, Chris Dale, back yet again with a Natas web hacking video. Over the Wire has this beautiful web hacking series, and I stopped producing these videos for a while because I didn't have time for it. However, then a lot of people reached out to me using YouTube comments or even via email asking me to continue the series. So of course I'm going to do so. Thank you very much for reaching out. That means a lot to me. So here we have an application that has some kind of security filters being added to it, and we can look for some kind of word list, I guess, looking for words containing, say, the word dog. Now, always try the functionality before you try hack it, right? That's our rule as pen testers. We want to see what is expected behavior before trying to make it behave erratically. So we look for the word dog, and now we can see that there's a bunch of words being outputted as dogs. Now, we remember this application. If you looked at my videos before, we've been through this already, and we could do command injection through characters such as semicolon, oh, didn't work, ampersand, didn't work. What about the pipe symbol? And that doesn't work either. Seems like they're filtering on all the stuff that we used before. We could also filter, we could also grep through multiple files in the challenge before. We could do something like look for the character A, for example, inside of both the etc Natas web pass, which is where the password for the next level is stored. We could grep through to see if this file contains the word A, and also the file that we're currently grepping through, assuming this is grep, of course. Now let's see what happens here. And that does not work. What if it's not an A? What if it's a B? Or what if it's a C? And so on. And I would go through every single character here just to see if it contains any of these characters. And what you will notice is that this output has been hardened. It does not reveal the output, the grep output from multiple files anymore. In fact, if we take a look at the grep manual, it does say that it will look for a pattern from an optional file, and it can be multiple files being grepped through here. So our attack here is actually not working when we look for say the character A inside of two files. And what we would expect to see is actually, let's set up a demo on this, because I love demonstrating to myself what is the intended behavior before trying to hack it. So whenever I have SQL injection, whenever I have command injection and so on, I will try to replicate the environment so I can learn and understand my attacks better. So I'm going to create a directory here called over the wire 16, yeah. And from here, let's create a pass.txt. So I'm just going to create a random string here, not random, but you get what the point is, into a file called pass.txt. And also let's create a dictionary.txt here containing some words. Let's take a look at words that has something to do with elf, for example. Look, these are nice words to put into our file here. Right quick. So now we have a way to do a sort of proof of concept to see if we can learn what type of behavior we're looking at here. So we do a grep, we have our input here, and then we're grepping through dictionary.txt. And what we try to do is we try to look for the word A inside of both etc Natas web pass and inside of the file Natas17. However, I just named this file pass.txt. Now, in my proof of concept, this works. And it doesn't work in the actual solutions, meaning that this avenue of attack has been patched. It doesn't work anymore. Now, what could we do instead? Now, here comes the attacker's methodology. And I've covered this in my minimal viable pen test methodology before, but we gotta enumerate the attack surface here. Which characters are allowed, which characters are not allowed. So what I'm gonna do is I'm gonna intercept a request where I'm looking for the word A. And I'm gonna send this to the intruder using Control I, or just send through intruder here. And I will tell this A word here to be a variable. And I will enumerate through every single possible byte, every single character that this can be. I'm gonna go through a null byte all the way through FF, and I'm gonna say hex values here, leaving me with 256 possible values. And I will add a percentage sign in front of my numbers to make it URL encoded. That will allow the web server to understand my input not as numbers but actually as bytes. And just for good measure, I'm gonna tell it to do a URL decode. So I'll actually send the raw bytes to the web server and to the application. Now, normally when I do testing, I like to have it both on and off just to see if there's any difference. Sometimes with URL decode turned on here, you will actually find vulnerabilities in load balancers, in proxies, in cache solutions, and in request handlers, and so on. And what type of output are we looking at here? We're looking for something that says that we have an illegal character. So the quote sign here is also illegal. So these words here, I don't see them represented anywhere else in the page. I don't expect these to be words in the dictionary file. So I'm going to add this as a filter item. And when I now do start attack, you'll notice that I have a column here that says illegal character. And I will flag every illegal character that I can find. And this kind of effectively finds which characters have been blocked by the application. It's a tremendous way of finding the attack surface, what type of characters are allowed, which are not. And we can see the quote here, we see the ampersand, even the backtick here and the tick, semicolon, all of these nice characters that we can use for command injection have been filtered. But there is more characters. And that's the problem with blacklisting. There will probably, most of the time, there will be some kind of character that you forgot to blacklist. Something, a clever attacker, someone who's smarter than you, he came up with another way of running a command and you forgot to blacklist that character. So why don't we instead whitelist stuff in our backend as developers? That would make it so much more secure. Maybe whitelist so that we can only look for alphanumeric, for example, and this problem would have been solved. So looking at these blacklisted characters, and also I did a lot of RTFM here, reading the fine manual, right? However, looking at the bash syntax history, the shell history, the shell syntax, looking through how Linux behaves with its terminals, I figured out that, hey, there's something called a subshell. Who would have known? A subshell that you can create without any of these characters. And in fact, the subshell looks like this. Say, for example, I echoed the word test, right? So we control this value test here. And we'll give it, say, maybe inside of here, we'll give it a subshell, a little $, and then parentheses. From within here, we can run new commands. Say, echo the word word. And notice that now my output is words. So I can put in anything I want to into the input here. Meaning that, say, for example, in our output here, let's do a grep, and we have our input here. I can do a subshell for dictionary. And I can look for any words inside of the dictionary containing, say, the string A, right? And this will output stuff. Now, of course, I want to verify this inside of the actual application. So let's go here, echo A, and we can see words that has something to do with A. So it seems like our proof of concept is actually working. Echo A gives us output of words that has something to do with A. But we're looking for the webpass file, Natas16. And we want to learn what that password is built up on. What if I did, for example, echo, say, for example, grep A, and see if it contains, whoop, that did not work. See if, for example, grep A is inside of pass.txt. So that did not work, but don't we have A inside of pass.txt? Why did that not work? What if I do a Z here and we have a hang? All of a sudden it's expecting an end of line, and I do a control D, and we have this type of like Boolean true or false. If I do cat pass.txt here, there is no Z. However, when I gave it an A, it did kind of fail on me. If I do a number, say, we don't have a number 3, we see it's hanging, control C. If we do a number, say, 2, we get no outputs. Now, that leads me to believe that we're looking for the word 2. The passive doesn't have the word 2 in it, so we don't get any outputs. So we kind of have to build a scenario that we can use for figuring out what this passive.txt contains here. Now, having a Boolean true-false type of condition, what if I said, look for the word, say, we have sculpt here. Sculpt. Now, sculpt 2, so this would actually return 2 sculpt in dictionary.txt. That would return me nothing. What if I did a number 3 now? And we get the word sculpt returned. Oh. So the end of line is hanging because there is no output of the command. It's still expecting some kind of like input to the next command here, this grep here for dictionary. So whenever we have something that does not exist inside of pass.txt, like the number 3 here, we get the output of scalp. But once we have something, it just returns nothing. That's a Boolean true false. Something existed versus something that did not exist. And I'm pretty sure we can expand on this. So let's take a look first. Let's take a look. So we take this output here, we do this, and instead of looking for pass.txt, we'll replace with Natas web pass, Natas16. So this output is now grabbing for number 2 inside of etc Natas web pass Natas17. And if it doesn't, so if that word 2 is contained inside of Natas17, we will look for a word inside of the dictionary.txt called toScalp. And that should not exist. So let's see if we can find a word scalp here. A scalp returns, meaning that the password should not contain the word 2. Does it contain 1? Nope. Does it contain, say, for example, an A? Ooh, yes. We now have in our web application attack, we can also see that we have a way to discern if the string contains a character or not. But this is no good, because looking at the previous challenges, the password is actually 32 bytes long, so 32 different characters, and we can't use this to brute force. What if we were to brute force all the possible characters? We would still have them jumbled up in all kinds of different orders, like this one here, for example, or it was an A, right? Is it the first character? Is it the last character? Is it one of the middle ones? Is there multiple A's and so on? So in theory, this is not good enough. So we have to build upon it. We have to build upon it. So what I was thinking is that maybe we can use regex. Now the dash character did not seem to be blacklisted, and it's not. So we can do a dash E, which turns grep into regex search. The parentheses are all good and so on. What if we were to look to see if the start of the string, that's a caret, it should start with, say, for example, the character A, and then it can have any character following arbitrary number of times till the end of string. Semicolon, also, sorry, this dollar sign here also works. So let's do this here. That returns the word scalp, which means that the password does not start with A, because if it was starting with A, we would look for the word a scalp, right? In fact, let's look at the pass.txt here. It starts with a capital A. So let's do a capital A. All of a sudden, no results. Beautiful. And that's how we're going to architect our attack here. So what I'll do is I will, from burpsuit here in our attack. In fact, let me do our attack in the browser first. So I'm going to do this all the way up here, right? So then we have a space here, just so I can keep the URL encoding and so on intact. And does the password start with an A? If it returns scalp, it does not. And maybe it starts with an A. Maybe I was unlucky. Let's do a B. Nope. Oh, I see what's wrong here. Grab here. There we go. Does it start with a B? No, it did not. What about the A? Did it start with an A? Nope. Does not start with an A or a B. So this is where I'm going to turn into fuzzing, because I don't want to try all the possible characters manually. So what I'll do, I'll capture the request, Control I, send to intruder, and looking at this URL encoded string, it can look a bit complex, but just highlight it if you're curious so you can see what it actually translates into. And I'm going to be looking for my character A in here. So here we have a dash E, and here we have a, this is the caret probably, and this is the character we want to be fuzzing. We want to go through every possible character from A to Z, numbers and also lowercase. So in my payload set here, I will say brute forcer. Right. So let's type in uppercase as well. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Pretty sure that's the alphabet. Who knows? It might be wrong. At least it's the English alphabet, right? No A, Ö, and O characters like we have in Norwegian. But 62 characters, that looks about right. So 26 times 2, 52 plus 10, 62. So I guess I didn't have any typos in there. Now, let's do a start attack. Let's see what kind of output we have. So 1362 in content length there. Oh, and here we have a different output. When we gave it the character A, it returns a different amount of bytes. In fact, I can sort on this now to find it easier. But if I were to look at the response here to the render tab, click the render page. Okay, there's a new update from Burp that I've been missing. Let's ignore that. Not sure what that's all about. If I look at the raw here, it says find words containing, and output here, nothing. Beautiful. However, for lowercase a, find words containing scalp. Yes. So we have the output. We have Boolean false, which is when the return is scope, and then we have the Boolean true, which is when we get the correct character 8, because that will turn the attack into saying that we're looking for the word 8 scalp, and that doesn't exist in the dictionary. So from here, I guess the solution would be now to prepend the word that I just found, 8, the character, and then look for the second character. Let's do this. Look for the smallest content length. There we have a P. Nice. So let's do a P now. Let's do a P here and go with the next character, capital P, mind you. And we can flesh this out. We can get the full password. Now this is going to be time consuming, 32 characters. Of course, if you want to put your money to it, you can make it work manually. However, sometimes you kind of got to step out of Burp Suite and do some manual scripting. I don't see any payloads here that would allow me to do this for me. Maybe I could create a macro. Maybe I could use Turbo Intruder in some kind of cool way. However, I did create a script just for this demo to show you how I would use Python to do this exact same enumeration. So this is, I don't use Python that much. I'm actually an old C Java developer, and I've been programming PHP, JavaScript, and so on. I'm used to the old school type of programming, and this new school Python type of thing is kind of like messing up with my head here. However, I did create a script so I could show you. First thing is I have some proxies set up just so I can use my Burp Suite to debug and control my inputs and outputs to the application. Always a good idea. So in all my request scripts here, where I'm using the request module, I will always have this in my header just because I want to troubleshoot through Burp Suite. Then I have a password which I set to an empty variable, and I'm going to go through numbers from 1 to 32. This is going to be representing the character position up here. So number 1, number 2, and then I'm going to build up all the way to I can see the last character. Now then I'm going to go through every character inside of the alphabet. Same thing as I did with the Burp Suite Intruder with the brute force module. I'm going to make a request in Natas16, and I'm gonna give it the header of the base, the clear text basic authentication here for the password for 16, and I'm gonna give it the necessary get parameters here, which is a needle. The needle contains the attack just as I have it up here. So this is simply a copy paste of what I had before. Now I'm using a different word. I'm using the word Zeus to like kind of prepend the word Zeus here. I'm giving a submit search, so I'm triggering the correct features of the application, and I'm using proxies, and then I basically, this will cause this request to be made out to the web server. Then I'm looking to see, I'm just saying in Python here, if the response from the web application does not contain the word Zeus, well, that means we just found a character for our password. So we're gonna take the password, the variable, we're going to add the current value, which is nothing for the first request, and add the character that we just found, essentially building out the entire password here. Then when we're done, we're going to output this request. I'm using Visual Studio Code, which is a beautiful IDE for development. I'm going to hit F5, I'm going to tell it to run, and now it's basically running a bunch of requests against the web server. Now from here, I can troubleshoot. I can go to my proxy, HTTP history, and you can see the requests that are being made here. So I can now figure out if I have some problems with, say, URL encoding, any problems with my headers, any problems with authentication. I can figure out why my script does not work, and that's so convenient, and I like to have that always. All right, so let's take a look at here. We have the first character 8, which matches our output from the web application 8, P, S, and so on. And it will just keep on rolling until it got all 32 characters. Now, I could probably speed this up a whole lot by doing maybe a binary search or something faster. but still, it gets the job done, right? And I'm just here to solve this challenge. So let's see what password we can get. And while this one is running, I'm gonna have, frankly, a sip of my beer. And that was lovely. Take a look at the time. It's actually 2:38 in the morning here in Norway. I just got off a call with a colleague. I had to help him with a local privilege escalation exploit, and we got it done. So I was so happy that I decided, hey, why not just open another beer and sit down with this video and see what, and see if I can make a video for you guys and make this this reality. Now, hopefully after this level, I'll have a good momentum. I'll create all the other levels as well. Make sure that everyone will get their walkthroughs of all the levels, so that hopefully you can learn something new, right? That's my goal with these videos as well. I want to make sure that I step through all the different steps that is necessary to grasp that understanding of what it takes to solve these challenges. I don't want to just show you the solution. I want to go through the methodology and my mindset when I'm trying to solve these challenges, because that's at least how I would want to learn. I wouldn't want to just copy paste some solutions, and that probably won't stick for you. Now let's see, how many characters do we have left here? Copy paste this one, and it must be almost done. Did I break it? So this is probably just about 32 right now, right? So I guess we're just gonna wait a few more seconds. Password found. Must be looking for the last few characters. Or maybe it's done actually. Maybe it never returned to the print done. Maybe I got a problem with my loop. Does not seem that it's returning anything more, so let's go to Natas16. Natas Labs over the wire.org. Natas17, try the password. And there we go. So, whatever caused this to not print this last line, maybe some of you guys watching knows. Maybe I need a new line here. I'm such a Python noob. I kind of hate Python, but I promise, I did it for you guys. I know you guys love Python. So there we have it. Another challenge solved. Now on to the next one, right? Check if username exists. Wow, this looks to be some kind of SQL injection to me, and I love SQL injection. So next video, we'll take a look at this one. Thank you guys for listening and paying attention to my videos. Leave a comment if you liked it, all right? And hit me up if you want to reach out with anything. All right, bye-bye, see you.